Hello, welcome to Algorhythm. Today we'll be solving LeetCode 2055, Plates Between Candles. In this question, we're given a string S that only contains the asterisk character and the vertical line character. The asterisk represents a plate, and the vertical line represents the candle. We're also given a bunch of queries, and these queries contain a left index and a right index. This left and right index denotes the substring that can be created using the given string S. And the goal of this question is to figure out the number of plates between the candles that are in the string. Now, one thing very important is that we only count the plates that are in between the candles in a given substring. So if you look at the given example, we're given a query of 1 and 17 right here. Now, this would create a substring as such. However, we don't count the plates from index 1 to 2 and 17 because they're not in between candles, right? They're just plates that are not in between candles. The plates that we count to be in between the candles are the plates that are in between these two candles because they're the leftmost and the rightmost candle within a given substring. Now the resulting answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, giving the result of 9. In order to derive the answer for the query 117, there were two important steps in order to solve the question. So in a given query of 1 to 17, how we solved the question was, first, we had to figure out what the leftmost and the rightmost candle is for a given substring. And we were able to figure out that for the given example of 1 to 17, the leftmost candle was 3, to rightmost candle being 16. And then we had to figure out number of plates between the left and rightmost candle. The problem breaks down into these two problems fundamentally. Now, let's look at the first process of finding the leftmost candle and the rightmost candle. With the given query of 1 and 17, the most naive way of figuring out which candle to decide as the leftmost candle and the rightmost candle, we give an index at the left and the right, and we just increment for the left one and decrement for the right one by one until we reach a candle, right? In the given example, it wasn't a costly operation to figure out what the leftmost and the rightmost candle is. However, given a lot of queries, let's say, for example, we're given queries of 117 and 217 and 017 and 118. Now, notice how for every single query in the given example, we're doing a lot of necessary repeated work, right? For the first one, we start here and here. We decrement once, increment twice, figure out the leftmost, rightmost, right? And then for the second query, we start at 2 and 17. We increment once, like even though we already incremented here before, decrement once again from the exact same spot. And in fact, 0 to 17, we actually do the most repeated work that we already done before to figure out the exact same result, right? So it's important to be able to record what the leftmost and the rightmost candle is for each index so that we don't do repeated work, right? Well, how would we record this, right? Notice how for these three indexes, the closest right candle is all index 3. And for these 4 and 5 indices, the closest is 6. And for these indices, the closest is 12. 13 and 14, closest is 15. So why don't we just compute what the closest right and closest left of each indices are? So we can have closest right and then closest left, such that for each index, we figure out the closest candle to the right or to the left to the corresponding position. So first, we figure out that the candles exist in index 3, 5, 12, 15, and 16, and 19. Then from here onwards, we just compare the two, right? So we just record 3, 3, 3, 3, right? The closest index to the third index is itself. And for the fourth index, we write 5, 5, 5, since that would be the closest right in candle and onwards, right? And closest left would be more advantageous for us to start at the rightmost index. So the closest left candle is 19 from the beginning and itself, and then 16, 16, and onwards, right? Notice how there's an edge case in these closest left and right list. What is the closest right candle for the last index? There isn't one, right? So why don't we indicate if there is no closest right candle to the given index to be out of bounds, 21. And then for the closest left, what's the closest left candle for these indexes? There isn't one, right? So why don't we again put it out of bounds to be -1, right? That way we figure out that there is no closest left candle for a given index, right? Because it's totally valid for us to get queries such as 0, 2, right? Then we return 0 because there is no closest left or right candle. So this way, we can immediately figure out what the closest left and closest right candle is for each index in big O of 1 time, right? We just have to compute the list and then look at it. So we compute it once, and then from that one point onwards, we can access it in big O of 1, which is better than doing it every time, right? Then since we solved the first problem, let's go to the second problem. If you look at the given example again, there are exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spots where the plates can be placed. And within that 12 spots, there are 3 candles. Therefore, we subtract 3 from 12 to get the answer of 9. To calculate the maximum number of plates possible in between the leftmost and the rightmost candle, we first take the corresponding indices, which is 16 minus 3, and then we minus one more because we are actually now counting for the left and rightmost candle. So if you look here, this 3 can never be a plate since it's a candle, right? So we take minus 1 here in order to account for that. So that's how we get 12, and then we subtract the number of candles between the leftmost and the rightmost candle. So to summarize, we get rightmost candle index subtract by leftmost candle index minus 1 and then minus number of candles between, right? This is how it's calculated, so we can all combine this into a code, and it's easily solvable. So let's get into the coding part of the question. So we have to return a list of answers for each query. So we'll have resulting variable, then we'll be filling it in with results, and then we'll return that result at the end, right? Now I'm gonna quickly write the processes that we talked about in comments so that we know what we're gonna do. Figure out leftmost and rightmost candle. And then we're going to figure out number of plates in between left and rightmost candle, right? Now, if you remember, the formula was rightmost candle minus leftmost candle minus 1 minus number of plates, number of candles, sorry, in between candles, right? I didn't go over too in detail because it was like a repeating work, but in order to get number of candles in between the candles is we get the rightmost candle minus leftmost candle, leftmost candle, and then subtract one again with the same reasoning. So what I mean by the if most candle and the leftmost candle, so if you're given a list of indices with candles like such, we'll actually make a hash map here where 3 would return 0, 5 would return 1, and 12 would return 2, right? So that's like this is the first 0th candle, and indexed at 5 is the first candle, indexed at 12 is the second candle in total. So first we'll get a list of candles with indices of where each candle is, and then we're going to have a hash map as we just talked about to get the place of the candles. We'll use a counter to give placements for each candle. So we'll have closest R and closest L, representing the closest left or right index of the candle for every index. So if you remember, closest left for the couple of indices, we'll have -1. So we'll just first set up the whole thing to be -1, and then we'll just update the values depending on what we get. Closest right, we'll have length of out of bounds length, right? Now, if you remember, we'll update each candle through last candle, and we'll do closest left first. So we would have -1, right? And we'll enumerate through the string to get the index and the contents for it. So if each character equals candle, we'll update correspondingly. So we'll update the candles list with the index, and then we'll give what place it is through the counter variable. Now we're going to update everything. So counter will +1 it, and last candle will be updated to be the current indexed. And then we'll update closest L with current index to be last candle. Now we're going to set last candle to length of S this time because we'll be iterating through closest R backwards, and the default value will be length of S, right? index in range of length of s -1, -1, -1. That's just iterating backwards, and that's like the fastest way to do it. So, but the whole code stays pretty much the same. If it's candle, we update it, the last candle to be that number. And the rest we don't have to do because this is just for getting the candles and candle map for the first time. We're just iterating and doing it at the same time to save time complexity. Now we update the closest R to be the index. I think I made a typo here. There should be an equal here. Should be last candle. And that's it. Now we're gonna figure out place in between left and rightmost candle for each query. So in order to do that, what we're gonna do is go through each query first. For each query in queries, we get query left, query right equals right, and then we'll get the leftmost candle and the rightmost candle. So candle left, candle right equals. So from the query left, we have to look at the closest right one. So right, query left, and then for the rightmost candle, we have to get the closest left of from the query right. Now we're gonna get number of plates using the formula that we wrote down. So candle right minus candle left -1, and this is gonna get a bit long, so I'm just gonna do the rest of the calculations on the next line, and we're gonna subtract number of candles in between candle, which is candles map dot get candle right, and if there is no such candles, we'll just return 0 minus candles map dot get candle left -0, and we subtract 1 as well, right? Because we're measuring from the leftmost candle +1, right? Now we are gonna append that to the resulting variable, but we want to use the max variable here because of the cases where there are no plates in between the substring, and the calculations here will sometimes lead to be negative values. If that's the case, we just return 0. And then that's it. And when we run, we pass the test, and we'll submit and see. I've passed. And that's it. Thank you very much.